Directions for this section is evaluate when A equals -5, B equals 6, and C equals 2.8. First question is the absolute value of -4b. Solving this, we can take the value for b, which is 6, plug it into the absolute value, and solve. -4b would be -4 times 6 inside the absolute values. -4 times 6 is -24. And the absolute value of -24 would be +24. The definition of an absolute value is the distance from 0, or in other words, the positive number without the negative sign. Second question, and last question for the section. Negative absolute value 2c minus a. Solving this one, the negative outside the absolute value would stay the same. 2 times c, c is 2.8. And minus a is a -5. Solving again, the negative outside the absolute value stays the same. Multiplying 2 times 2.8 would be 5.6. A minus a -5. Anytime you have minus minus, we can change that to two positives or plus plus. So it would change to 5.6 plus 5. The negative outside the absolute value again stays the same. 5.6 plus 5 would be 10.6. The absolute value of 10.6 would still be 10.6, and the negative outside the absolute value would make the final answer -10.6. Title of the next section is Solving Equations. With absolute values. In this section we'll have equations. The equations will have absolute values, and we'll solve for the variable. One definition or topic to keep in mind when solving equations with absolute value is to check solutions. Sometimes when solving equations with absolute values, you'll get the correct solution mathematically from the equation, but the answer will not work in the original question. So anytime you get an answer for an absolute value equation, always make sure to check solutions by taking the answer, plugging it back into the original equation, and making sure it works. The first question for the section is the absolute value of x minus 25 equals 17. To solve absolute value equations, we'll end up getting two answers or two equations. The first equation, we can remove the absolute value signs. So we just have x minus 25 equals 17. For a second equation we can solve to get the second answer, Again, we can remove the absolute value signs, which would be x minus 25. But instead of equaling 17, the second equation will equal the opposite, or negative 17. The reason we can use negative 17 is because if the absolute value is equal to negative 17, the absolute value of that would still be 17. Solving the first equation, we can add 25 to both sides, and x equals 42. The second answer, or second equation, again, we can add 25 to both sides, and x equals 8. So we have two answers, or two possible answers, x equals 42 and x equals 8. Keep in mind though, we always want to check solutions, especially on absolute value equations. To do that, we can take our first answer, 42. If we plug it back into the original equation, 42 minus 25 would be 17, and the absolute value of 17 is equal to 17. So 42 works as a solution. Our second answer, 8. Plug it back into the original equation, 8 minus 25 would be negative 17. The absolute value of negative 17 is 17. So 8 also works. So the two solutions are 42 and positive 8. Second question for the section is 8 times the absolute value of w minus 7 equals 72. To solve this equation, what we want to do before we write the two separate equations to solve is to isolate or get the absolute value by itself. For this equation, we have to move the 8 to the other side. Since this is 8 times the absolute value, we can divide both sides by 8. That way we're left with just the absolute value on one side, w minus 7, and equals 9. From here, when you have the absolute value equal to a number, to find the two solutions or two possible solutions, we can remove the absolute value signs, which will be w minus 7 equals 9. And for our second equation, again, we'll remove the absolute value signs, w minus 7, but instead we'll set that equal to negative 9. And again, we use the opposite of the number, negative 9, because when we take the absolute value of negative 9, that would still equal 9. Solving the two equations, we can add 7 to both sides. Our first possible answer, 9 plus 7 is 16. And our second equation, add 7 to both sides. So w is equal to negative 2. Again, we have two answers, or two possible answers for the absolute value equation. Keep in mind these numbers, especially for absolute value equations, you want to plug back to the original question. For example, if we have 16, 16 minus 7 would be 9. The absolute value of 9 is also 9. 9 times 8 is 72, so the first one works. Second possible answer, negative 2. If you plug a negative 2 into the original equation, negative 2 minus 7 is negative 9, and the absolute value of negative 9 is positive 9. Positive 9 times 8 would be 72. So the second solution also works. So again, we have two answers, w equals 16 and w equals negative 2. And the last question for the section, we have the absolute value of 3n plus 2 plus 4 outside the absolute value equals 0. Solving this question, again, the first step is to isolate the absolute value, or get the absolute value by itself, which means we have to move this positive 4 to the opposite side. To do that, we can subtract 4 on both sides. Absolute value of 3n plus 2 would stay the same, and 0 minus 4 would equal negative 4. From here, if you wanted to, you could take off the absolute value, have 3n plus 2, set it equal to two numbers, go through and solve, and then check the solutions. One shortcut on this question, if you look at the equation, we have the absolute value of 3n plus 2 equals negative 4, or equals a negative number. If you think about absolute values, it does not matter what's inside the absolute value. When you take the absolute value, this will be a positive number. It can never equal a negative number or equal negative 4. So in this case, since it's equal to a negative number with the absolute value signs, the answer to this would be no solution. If you did solve this problem out, set it equal to negative 4 and positive 4, you get two answers. Plugging those answers in, neither one would work for the original equation. So again, no solution would be the answer to this question. Title of the last section for this section is Variables on both sides. For the section, we'll still use absolute value equations. Solving these, we'll have variables on both sides of the original equation. For the section, the same definition or something to keep in mind for all absolute value equations is always check solutions. Again, by checking solutions, verifying the answer still works. But again, on some absolute value equations, all the work can be correct when you're solving the equation, but when you check solutions, the answer will not work and will be eliminated as a possible solution. First question we'll solve is 3 times the absolute value of p minus 5 equals 2p. Again, for these questions, we will have variables on both sides of the equations. Before we solve absolute value equations and have the two equations with the two possible answers, the absolute value must be isolated or by itself. So in this case, the 3, we need to move to the other side. This is 3 times the absolute value. So we can divide both sides by 3 to cancel out or move the 3 over. P minus 5 stays the same inside the absolute value, and we'll have a fraction 2/3 p. To solve from here, when the absolute value is by itself, again, you can take the absolute value signs off, p minus 5, and set it equal to 2/3 p. The second equation we can solve, p minus 5 would stay the same. But again, instead of equals 2/3 p, we'll do the opposite, which is negative 2/3 p. And again, we'll do the opposite, because if the absolute value is equal to negative 2/3 p, then the absolute value answer would still be 2/3 p. Solving the original equation, we can subtract p on both sides. That way the variables all go to the right hand side. Negative 5 would stay the same. 2/3 p minus 1p. You can get common denominators on those. 2/3 p would stay the same. And instead of minus 1p or minus p, you can change 1 into 3/3 or minus 3/3p. Negative 5 stays the same. And now we have common denominators. 2/3 minus 3/3 would be negative 1/3 p. To get rid of a fraction, negative 1/3 times p, we can multiply by the reciprocal. Reciprocal of negative 1/3 would be negative 3/1, which will multiply on both sides. Negative 3/1, or just negative 3, times negative 5 would be 15. The right hand side, the 3's would cancel, the 1's would cancel, and the negative cancels. So the reciprocals cancel out, and we're just left with p. So again, one possible answer to the first equation is 15 equals p, or p equals 15. The second equation that we had written earlier, equal to negative 2/3 p. Same steps, we can subtract p on both sides. Negative 5 again stays the same. And again, we'll need common denominators to subtract fractions. Negative 2/3 p would stay the same. And negative 1 we can change into negative 3/3 p. Solving from here, negative 5 stays the same. Negative 2/3 minus 3/3 would be negative 5/3 p. Solving from here, to get rid of a fraction that we're multiplying by, you can always multiply by the reciprocal. Negative 5/3, the reciprocal will be negative 3/5. And we'll multiply that on both sides. Multiplying negative 3/5 times negative 5. Negative 5 you can make a fraction. Negative 5/1. You could multiply and then divide. You can also cross cancel the 5's. The negative would still be left, but 5's would cancel. So we have a negative 3 times a negative, which would be positive 3. Multiplying the right side fractions. Again, you could multiply straight across and then simplify. Or a little easier method, we can cross cancel the 3 with the negative 3. But again, the negative would still be left. And we can also cancel the negative 5 and 5. But again, the negative will still be left. So we'll have two negatives, like two negative 1's. Multiplying those, that would be positive. We have a p left, so that would be positive 3. So again, our answer, or possible answer, 3 equals p, or p equals 3. Always, again, to double check answers on absolute values, or two possible answers. Make sure you double check by plugging back into the original equation to verify that they work. First answer, 15. If we do 15 minus 5, that would be 10. Absolute value of 10 would still be 10, times 3 would be 30. So the left-hand side would equal 30. If you plug a 15 into the right-hand side, 2 times p, 15 times 2 would be 30, and 30 would equal 30. So the first answer, 15, does work. If you check the second answer, 3, plug a 3 into the absolute value. 3 minus 5 would be negative 2. Absolute value of negative 2 is positive 2, times 3 would be 6 for the left-hand side. And plugging a 3 into the right-hand side, which was originally 2p, 2 times 3 would be 6. So 6 equals 6, which is true, which means the answer is also true. So two answers that do work, 15 and 3. Second question for the section, and last question. equation is 16y equals 4. Inside absolute value, 3y plus 8. Again, for the section, we have variables on both sides that we'll be solving. Absolute values, before we solve, the absolute value again has to be isolated by itself. So in this case, the 4 we have to move to the left-hand side. Again, this is 4 times the absolute value. Opposite of multiplying by 4, we can divide both sides by 4. So our equation would be 4y. The 4's would cancel on the left, and we'll have 3y plus 8 inside absolute value. Once we have the absolute value again isolated, we can solve 2 equations from here. First equation, 4y would stay the same, and you can remove the absolute value signs, 3y plus 8. For the second equation we'll solve, instead of positive 4y, the number or term outside the absolute value, we'll change that to make it a negative 4y. And again, what's inside the absolute value stays the same, but you can remove the absolute value signs. Solving each equation, 4y equals 3y plus 8. We can subtract 3y on both sides. 4y minus 3y would be 1y or just y. 3y would cancel, and we have the answer, or again possible answer, y equals 8. Second question, or second equation that we have on the right hand side. Same steps, we can subtract 3y on both sides. Negative 4y minus 3y would be negative 7y. And again, the 3y's would cancel on the right hand side and equals 8. Solving from here, negative 7y. We can divide by negative 7. So the negative 7's cancel. And our second possible answer will have a fraction negative 8 over 7. Keep in mind these are 2 answers or 2 possible answers. To verify that they work, we'll want to plug them in back to the original equation. On this question, one of these answers will not be a solution. To check which one, I'll rewrite the original equation. 16y equals 4 absolute value of 3y plus 8. Our 2 possible answers, y equals 8 and y equals negative 8 over 7. We'll plug in the 8 first. 16 times 8. And for 3y, which would be 3 times 8, and plus 8. 16 times 8. If you multiply that out, it comes out to 128. 4 stays outside the absolute value. 3 times 8 would be 24, and plus 8. 128 stays the same. 4 would stay the same. 24 plus 8 would be 32. And 128 equals, the absolute value of 32 would still be 32, and times 4 is 128. 128 equals 128, which is true, which means this answer, y equals 8, does work and is a correct solution. The second possible answer, y equals negative 8 over 7. Again, we'll take the same original equation and plug in negative 8 over 7. So we'll have 16y, but instead of y, we'll have negative 8 over 7 equals 4 times the absolute value of 3, negative 8 over 7 instead of y. And plus 8 inside the absolute value. Solving from here, 16 times negative 8 over 7 The 16 you can make a fraction, 16 over 1, and then multiply straight across the numerators and denominators. 16 times negative 8 would be negative 128, and 1 times 7 would be 7. The right hand side, 4 would stay the same. 3 times negative 8 over 7. Again, 3 we can make a fraction by putting a 1 for the denominator. 3 times a negative 8 would be negative 24, and 1 times 7 would be 7. Plus 8. Instead of plus 8, we want common denominators for the next step. So the 8, I'll change to 8 over 1. And to get common denominators, we can multiply this fraction by 7 in the numerator and 7 in the denominator. 8 times 7 would be 56, and 1 times 7 would be 7. Solving from here, negative 128 over 7 stays the same on the left-hand side. 4 stays the same outside the absolute value. And combining fractions, negative 24 over 7 plus 56 over 7. 56 minus 24 would be 32 over 7. Negative 128 over 7 stays the same on the left-hand side. 32 over 7, the absolute value would stay the same. Multiplying by 4, we can change the 4 to a fraction, 4 over 1. And multiplying 4 times 32, that would be 128. And 1 times 7 would be 7. Negative 128 over 7 does not equal positive 128 over 7. So in this case, our solution at the top was a correct solution for the equation that we solved, negative 8 over 7. But upon verifying, plugging that number back in, checking the solution, it does not work, which means y equals negative 8 over 7 is not a solution for this equation. And our only answer would be y equals 8. Title of the first section is Graphing. Inequalities. First problem is x is less than 5. When we're graphing inequalities with a single variable, the graph will just be on a single number line. There are several ways to draw a number line. One possible solution, how you can draw this number line, is the answer 5. We can put in the middle of the number line. And I'll put one number to the right, which is 6, and one number to the left, which is 4. If you want to, you could start your number line at 0 and count up to 5, or have several different numbers on there. To graph inequalities, inequalities will have circles, either open circles or closed circles. In this case, we have the less than symbol. The less than symbol is an open circle. The open circle for this graph I'll put above the number line. If you want to, you could put the circle on top of the number line. And the last part for the graph, the line will either go to the left or to the right. In this case, again, we have less than, x is less than 5, meaning we want these smaller numbers, which will go to the left. And that would be the graph for the inequality, x is less than 5. Second question and last question for the section. Y is greater than or equal to negative 3. And again, graphing a single variable means we can draw a single